good for the lesson today, Mr. Bones. Woo, that got a bit foggy. Oh, hi. Welcome to today's lesson. Lesson number 3 for week 3. What are the 4 states of matter? Me and Mr. Bones were just working on some interesting things to check out for later on, so it'll be cool once we get to that. So, what are the 4 states of matter? First, we have to talk about this cat. It's the atom. You're going to be learning a lot more about atoms this year, but today I'm just going to give you a little hint of it so that we know what we're talking about when we talk about matter. So the first thing is, what is matter made of? A lot of people didn't know this for a long time, and they used the scientific method to figure out what matter was actually made of, because they thought it was different things from different worlds, like no clue. And through science, they figured it all out. And it all came down to what the atoms are doing inside the particular types of matter. So inside of an atom, there's a nucleus, which is made up of neutrons and protons. So protons, you'll see that little positive. If you ever look on a battery, you'll notice that on one side there's a little positive. That's positive versus negative, so protons are going to be positive. Around the outside of the nucleus, there are these energy shells, kind of like the shells of an egg, which has the little yolk in the inside, the yolk on the inside. That's the neutrons and protons. The shell on the outside, those are the electrons. So electrons are negatively charged, and they're the ones that hang out with the other electrons from other atoms, and they sort of hang out and they're like, hey, you want to hang out? It's cool. And that is how matter is formed, by those electrons interacting with each other and hanging out and forming these big matrices and these big awesome things that we use in our daily lives. So I've got a couple pictures coming up, and I've used a big dot, which is the nucleus, which is for the neutrons and protons. And for the electrons, I made these little piggy tails here. So the piggy tails, if you see those are the electrons and how they're interacting and hanging on to each other. Think of them like having 2 slinkies, like 2 springs, that are kind of winding into each other and hanging on to each other so that it makes one giant slinky, all right? So there's 4 states of matter. There's plasma, solid, liquid, and gas. And interesting little story from me, when I was a kid, there was only 3 states of matter. There was gas, liquid, and solid. Plasma, they hadn't found it yet. Some scientists were looking into it, but they weren't sure if it actually existed or not. So it took many years of research and experimentation until they finally figured it out that it was an actual 4th state of matter. And I've been reading recently in some of my scientific magazines that they're working on finding out if there's a 5th state. It isn't official yet. They're still doing all the research and they're still doing all the experiments, but they think there may be a 5th state of matter, and right now they're trying to figure it out. So by the time you're as old as Mr. Music, or maybe even as old as Mr. Bones, there'll be another state of matter. So all those students that are coming up, they're going to be like, 5 states, why did they ever think there was 4? And I have to go, 4? In my day, there was only 3. So these are the 4 states of matter. There is a solid like a rock, or like the floor, or like Mr. Bones' noggin here, all solids. If you notice, the atoms are held very tightly. I do big black bars. They're really tightly and compact. They don't like getting very far from each other. Imagine you and all your friends have your elbows interlinked, all in a circle, and you're like, no. And people are trying to pull you apart, but you're just locked in there, and no, you're not letting go at all. That's how solids are. These atoms, they're still moving. They're just moving really close together, and they don't want to get very far apart. So if you try to pull them apart, they're like, no, and they just hang in there, and they hang on, they vibrate. So even though you touch something that might feel solid, it's still moving really small. It's really small movements, but it feels to us hard, solid. Liquid. Now, the atoms in liquid, as you know, you can see the little pigtails, the electrons. There's no hard bars there. Liquid's cool. Liquid likes roaming. It likes flowing. It likes moving around, but it doesn't like leaving its friends. So this is more like you're holding hands. Sometimes you get close, sometimes you get far. You're kind of dancing around, but you never let go of each other's hands. That way you can be flopsy. If you want to go over here, maybe you'll drag your friends with you. Maybe they'll go over here and they'll drag with you. And they'll just drag around. Mr. Bones is solid. He ain't going nowhere. Me and my friends, woo! We're all liquid. We're just floating all over the place, but we don't ever let go of each other's hands. All right? Now gas. Gas don't care. Gas can go this way, it can go that way. Gas will fill whatever area it's in. Notice it's just sitting there, it's got its little pigtails, it's bouncing around. If it runs into one of its friends, it's like, boop, and it just goes off. It's like running around the playground with your friends all over the place. Gas is everywhere. Sometimes it's moving really fast, sometimes it's moving really slowly. But it just goes wherever it wants. It can hang out with its buddies, it cannot hang out with its buddies, it can intermingle with other gases. Gas don't care. Gas is just out there traveling around. It's seeing as much as it can all over the place. And now we hit plasma, the new one, the new kid on the block, so to speak. Now plasma, you'll only find in a very few select locations, which is why it's really hard for us to figure out. In fact, on the Earth, it only happens in 2 places naturally, which we'll discuss a little later. But in the universe, plasma is 99% of all matter. So that's like everything. If you have 100 of something and you look it back at 99, all that 99, that's plasma. But if it's the most, why was it the hardest for us to find? That's because it doesn't exist on the Earth in very many places. In the places it does exist, it's really hard for us to figure out. It's hard for us to analyze it. It's hard for us to research it. And it's very difficult for us to take samples of it. You just can't take a sample and like say, look, got me some plasma in my hand. Now what plasma is, if you notice, those little pigtails, they're floating free. Notice these big dots in the nucleus? They're floating free. Plasma has so much energy, which usually is a lot of heat, and it's so hot that the electrons just can't, it doesn't want to be there. The electrons just break away, and the nucleus goes over here. But the electron's like, I want to hang out with you, and it keeps trying to grab onto it, but then it's like, oh, it's too hot. So like, imagine the hottest day of summer. It's so hot. And you have your heaviest jacket on because it feels really comfortable. And you're like, oh, it's so comfortable. But then you're like, oh, whew, this is really hot. So you take your jacket off and you're like, oh, that feels better. But then you start to feel uncomfortable. So you're like, I kind of want my jacket back on. So you put your jacket back on. Now it gets really hot. So your jacket comes off. And just keep doing that over and over again. And that's what plasma is. It's constantly like losing its jacket, putting it back on, losing its jacket, putting it back on, and it's all over the place. And it has properties which only it exhibits. Plasma, like gas, fills whatever area it wants, but it's always trying to come back to itself. And it's really amazing. And we'll discuss what plasma is in just a minute. So we want to now try to figure out if we can identify the states of matter in our normal daily lives. Well, I made a little chart here so that you can write down what states of matter you find around. So we know there's 4. There's solid, liquid, gas, and plasma. So solid, liquid, gas, and plasma. And now I'm just going to look around and see what's out here. So I made a little table here so we could look at some that I found just in the classroom. So down here at the table, Mr. Bones has collected a few items from around our laboratory. And rocks, fossils, these things are hard. They don't want to be anything else except for a rock or fossil. They want to look this way, they want to be this way, this is the shape they are. They don't want to change. This is a solid. That's all a solid wants to do. It wants to be that way. Then we have a liquid. Thank you for the beaker of liquid. We have a liquid here, and if you notice, as I tilt it, the liquid, it stays together, but it changes shape. It changes shape to fill whatever it's in. So I can put this liquid in a different vessel. Guess what? It's going to look like the other vessel. It's going to continue to change its shape, but all those atoms are just hanging hands. They're like, yeah, we're going to float around. We're going to be whatever we want to be. We're going to change shape to whatever shape we want, but we're still going to be hanging out. We're just a liquid. And then we have a gas. So guess what's in here? A gas. See it? It's right there. It's right inside. See it? Oh wait, this is empty. I'm going to scoop some gas. Getting some gas. Now it's filled with gas. Oh, it smells good. Gas tastes really good. Oh, but if you want to see a gas, get a kettle, put it to boil, water vapor comes out. Water vapor is a gas. So I'm gonna heat this kettle up and see if I can catch some of that water vapor in here, and we'll see if we can see that gas. So it's gonna take us a minute. Ooh. So you can start to see right here, there's condensation around the edge. And that condensation is the gas that water turns into when it gets really hot. And then it wants to go exploring, and it's filling this with water vapor. And once it condenses, turns back to liquid and starts to drip right off the edge. Oh yeah. And you can even see it rising as steam from here. Now to the newest state of matter that was found. This is plasma. Inside of this, there's a really strong electric current, and there's a gas inside of this orb. And what's happening is that electric current is causing that gas to break the electrons away. And what you're seeing is all those electrons collecting and trying to leap away from that high source in the center to the outside, because it wants to find its nucleuses. It wants to hang out with the nucleus. It wants to put that jacket on for comfort. It's like, I need my nucleus. And if you touch it, now it's looking at my finger and it's seeing the atoms in my finger and it wants to join up with them. Oh, I know. It really, all those electrons really want to be friends here. So if you look at this in my plasma orb, you'll notice that it looks really similar to one of the effects of plasma that we have on our planet. And that's lightning. Yes, lightning, exactly. So lightning starts up in the clouds or on the ground, and you'll have a whole bunch of those nucleuses. So it's really positive, lots of protons hanging out there. And on the other side, you'll have a whole bunch of electrons just waiting, looking for someone that you can jump to. And so it can be a nice coat or blanket over them to give them comfort. And what happens is they get so many that the space between them isn't enough, and they all group up really fast and suddenly, and they leap up to the clouds, or they leap from the clouds down to the ground. And what you see when you see that lightning is you see all those electrons forming a giant train, just trying to find its buddies and trying just as hard as it can to get up there. And when they get really hot and they give off a lot of light and they make a sound, because you can actually hear them exploding as just going up to the top there. The other places that we have plasma are in the borealises. So there's the aurora borealis and there's the Antarctic borealis. And those glowing lights in the sky that are just waves and waves of plasma just floating up there. And when you listen, if you ever get to see them, you can hear them crackling. And that's just like lightning, it's just little bits of it, just not one giant bolt, just like small, like sheets of plasma crackling across the sky. And that's it for the Earth. Other than inside of labs where they have very special setups to make plasma, it doesn't happen anywhere on the planet naturally that we know of yet. Science is always learning. But plasma is 99% of all matter. So where is the rest of the plasma if it's not here? We just have to look up. All of the stars are made of plasma. Our sun is a giant ball of plasma. Stars make up 99% of all the matter in the universe. Stars are huge. Planets are teeny tiny in comparison. So this, which we only just discovered and just figured out how to control and realize that we have it happen in a couple spots on our planet, is most of what fills the universe as far as we know now. So make your chart, look around, and see if you can identify other sources of matter for our state. So there's solid, liquid, gas, and plasma. As I said, we really have the four. You have the borealises, you have lightning, you have the sun, and you have stars. You could say the sun and the stars are the same, but we like to think of them as just a little bit different. And that's it for today's science. So start looking around. Bye.